Hey everybody, it's the Deephaven community team here again. It's January week 3. We got a short demo here from Devin showing some multi-hop barrage. Here we go. All
Hey
right.
everybody. Looks like you can see my screen bender.
Yep.
Great. So I want to give a little bit of a graphical setup for what you're going to see in the coming demo. It's a short demo, but there is a lot of setup behind it. Each of these boxes right here is a Deephaven community container. So in this graph, we've got 7 separate Deephaven community containers, and all of these links represent Barrage flows of data. And the flows are actually reversed, so this is from client to server, and so the data flows from the bottom of this graph up. So for example, there's going to be a table at this Deephaven 00 that all of these people subscribe to all these other containers subscribe to directly, but it's also the same data is going through a hop right here and a hop right here and a hop right here and a hop and so forth. So the idea is how much overhead do all these hops add to the barrage flow? So for example, when we're up here at Deephaven 06, we can compare the table that we've gotten via these 6 proxies versus the one that we get directly. And so it's basically just a ticking timestamp that we're going to be flowing through this whole graph, and we'll be able to take a look at it. But the one caveat here is it's not actually going to be 7 containers, it's going to be 48 containers. So I didn't want to make a graph that big to display, but we've got 48 containers. And just to talk a little bit more about them, all of the containers will be limited to a quarter of a CPU and 1 GB of memory, and I'll show you how I've set that up a little bit later. Before I do that though, I will give a shout out to this Mermaid live editor. It was very easy to create this graph, and so I'd suggest other people take a look at it if you need to create similar graphs really quickly.
It
So that
integrates
was
with
fun.
GitHub too. It's nice.
Oh, nice. Yeah, so this was a useful tool in describing the setup here. And so if we go into the actual code, what you'll see is um, we've got a way to compare time deltas between tables. Um, each server is passed an index as an environment variable, so it knows which server it is. Then it starts up with some information about the server, so it knows its server index, it knows what time it starts, and then knows how many CPUs it has, just for showing some static information. Then it creates its own timetable, and then it subscribes via URI to its the previous server's index. So this is server index -1, and this is a URI, which you can learn about in some of our other documentation. And then this is the direct subscription that we saw earlier. So it's subscribing directly to 00. And again, this is chaining, and it's set up in a custom Docker image with this start script starting automatically on startup. And basically I have a little Docker script that starts 48 of these. And as you can see, I'm limiting all of them to just a quarter CPU and 1 GB of memory so I don't blow up my machine. And then I wait until each image is healthy, and then I start the next one so it can successfully get its subscription set up. And again, it kind of looks like this. So each machine basically has 2 subscriptions, one to its immediate neighbor and one to the root. And originally what I thought was going to happen is I was thinking that each of these would introduce a little bit of delay, modulo the UGP cycle time, which is usually 1 second. So I assumed that on average there would be about half a second of latency per hop here. But what we actually see, and so I'm going to go ahead and jump right to the end node here, which is Deephaven 047, and that's represented on this port right here. If we look at the direct versus the proxy data, there is 0 seconds of delay between those timestamps. And I chatted with Nate a little bit more specifically about this. And what happens is that due to the batching, if the barrage message or the barrage infrastructure hasn't received any updates for a while and it receives a new batch of updates, it'll send those out immediately. So instead of waiting for the normal UGP cycle, when Deephaven 00 updates, it sends it to 01 and then immediately gets sent to 02 and so on and so forth. The end result being that there isn't much of a difference from 47 hops between this whole kind of proxy orchestration setup and subscribing directly. Now, sometimes it will be incurring an extra UGP cycle somewhere along this chain, and it'll be 1 second or 2 seconds. But a lot of the time, I'm noticing that the delay is 0 seconds, which is kind of an interesting observation here. You can see this is, server 47. It's got a quarter CPU, and this is when it started. And of course, I could jump to any other server here. So I'll jump to server 32, and we'll see something very similar. So this is server 32, and it's got all its data. So that was, yeah, quick show, and I can show you that I've actually got 48 containers running here. This is the root Deephaven 00 container. And again, it only can go up to a maximum of 25% of the CPU, but it's barely using any CPU. You can see over time the amount of traffic that it sends has been going up. But you can see I actually do have 48 containers running here, proxying that Barrage data. So that was, yeah, that was the demo.
Right on. Well, Barrage is just a hop and a skip away. We'll see you next week with another demo update. Cheers.